Morning to all, and morning, Professor. First, I would like to give my sincere thanks to our Professor for providing this wonderful opportunity to me. Dear students, in this lecture video, I'm going to talk about nanochemistry. First, let us see about chemistry. I hope you are all know very well know about chemistry. Chemistry is nothing but a chemical reaction between the reactants and evaluation of properties of product and the application of the product. The product may be in the form of organic, inorganic, or organometallic compounds. So generally, chemical reaction is performed by using different form of energy resources. The one best example is heat. So in this image, you can see that wood is burning. So wood burning reaction is a kind of oxidation reaction. How it happens? In presence of heat, the wood, which composed of a carbon and hydrogen material, is burning with the oxygen, and it will form carbon dioxide, water, and many other volatile organic compounds. So we can say this kind of reaction or thermochemical reaction. On the other hand, chemical reactions can also be performed by using light. The best example is photosynthesis. Plants doing photosynthesis and thus they can produce food for us. Photosynthesis is nothing but the reaction between carbon dioxide and the water in presence of light. They will form carbohydrate and oxygen. Even electrical energy can also be used to perform a chemical reaction. The best example is a lightning process. During lightning, nitrogen gas present in the atmosphere will be converted into nitrate. So you know that sound maybe in the form of music we are hearing. Sound can also perform a reaction. Such reactions are called sonochemical reactions. Nowadays, different kinds of organic and even inorganic compounds can be prepared by using sound energy. So, chemical reactions not only occur or happen in the environment, but also we can perform in laboratory. You might have many experience for doing chemical reactions, and I want to point it out two more things. The chemistry of sleep. Sleep is because of chemistry, particularly due to the chemical compound melatonin, and we're all having love, and love. The feeling of love is also because of dopamine molecule. So I want to say that chemical reactions produces product, and that product will be applied in different form. For example, in this case, sleep, we get sleep because of chemical product melatonin, because of melatonin, and our feeling, love feeling is because of dopamine. Different chemical products can also be used in different sectors. We are using many kinds of chemical products in our day-to-day life. Okay. So another word or term is nano. So what is nano? So the word nano is derived from a Greek word nanos. So nanos means dwarf or small. Small actually it is a relative term. When compared with 1 kilometer, 100 meter is small. And compared to 100 meter, 1 millimeter is small. compared to 1 millimeter, 1 micrometer is small. So in terms of material scientist, in material science, nano is defined as 1 billion or 10 to the power of minus 9 meter. This is the definition for nano. So that means your particles, you know that particles may be in a three-dimensional shape. Some particles may be in one-dimensional, two-dimensional, three-dimensional. So at least any one of the dimension exists in the 10 to the power of minus 9 meter, then that particles or material is called as nanomaterials. So nanomaterials exist in nature. For example, the butterfly. The blue color of the butterfly is because of a nanostructured organic molecules. It's not because of pigment. It is because of nanostructured material. And in the river, we can see the yellowish product. That yellowish product is nothing but the iron oxide nanomaterials. You can see this leaf, it's called a lotus leaf. Water won't wet this lotus leaf, and this is also this hydrophobic property is also because of nanomaterials present in this leaf. And you know this is a toucan bird. Its beak is very hard, and very hardness is due to the nanostructured materials. So nanotechnology is not a new one, it already exists in nature. And several natural process also brings nanomaterials. You can see the volcanic eruption. During volcanic eruption, nanomaterials are formed, gasmic dust. And weathering process will also form varieties of nanomaterials. Wind erosion, abiotic factors. These varieties of natural phenomenon produces varieties of nanomaterials in the earth. Is it possible to prepare nanomaterials in laboratory? Yes, definitely. So we can prepare nanomaterials in lab. And before that, I want to mention one thing. So nanoparticles, you know that the size should be in 1 to 100 nanometer, at least in one dimension. Suppose if the particles have less than 10 nanometer, we can say the particles diameter or length is 1 to 10 nanometer, then we can say they are quantum dots. One important thing is the Nobel Prize for Chemistry for this year was announced for three scientists from USA because of their discovery and synthesis of quantum dots. So in successive slides, we are going to see different synthesis methods for inorganic nanomaterials. So first method is a precipitation method. So in precipitation method, we need metal source and precipitating reagent. Precipitating reagent maybe a base or any complexing agent like carboxylic acid. For example, ferrous sulfate is a metal source. It should be taken in a solution form, and oxalic acid should also be added. Then what will happen is the iron sulfate reacts with carboxylic acid and it will form ferrous oxalate. Ferrous oxalate is insoluble in water, therefore it will be settled down. It will be precipitated in solution. Then this ferrous oxalate will be centrifuge or separated from the reaction mixture either by filtration process or centrifugation method, and then we have to calcine in a furnace. then we're going to get iron oxide material. The iron oxide material possesses some rod-like morphology. The size is in the nanometer size also. And another example is a solvothermal method. Solvo means a solvent, thermal means a heat energy. We have to take the reactants and a solvent. The solvent may be a water or ethanol or any other non-aqueous solvent. And we need to give some heat energy. Then what will happen is the reactants undergoes reaction, then they will form a product simultaneously. So in case if you use only water as a solvent for this reaction, then we can say it is an hydrothermal reaction. Okay. So generally for a hydrothermal or solvothermal reaction, we need an autoclave. Autoclave, yeah, special equipment is required, and Fe2O3 nanocubes but prepared by using a solvothermal method here. So another one is hydrolysis. Generally, you know that for a chemical reaction, previously we have discussed precipitation as well as hydrothermal or solvothermal method. We have used water as a simple solvent, water as a solvent. But in case of hydrolysis, water is one of the reactants. Ferric ion reacts with the water molecule at 90 degrees Celsius, then it will form iron oxyhydroxide, and subsequently it will also lead iron oxyhydroxide, and it will be precipitated in water. So we don't need to add any other reagent. Simply we can put a ferric salt in water, then we will going to get iron oxyhydroxide precipitate. It will be separated from the water, and then we can calcine the powder in a muffle furnace, then we can get a iron oxide material. What's the difference between hydrolysis and precipitating method? So in precipitating method, we need to add precipitating agent. But in hydrolysis, we don't need to add any precipitating agent. Instead of that, the water is one of the reagent here. This is the difference. So next method is a thermal decomposition method. So thermal decomposition is nothing but a molecule will undergoes decomposition, then it will form a product. For example, if you take iron acetate and calcine in a muffle furnace at 400 degrees Celsius for 5 hours, then we can get Fe2O3 material. This acetate ions will be leave as either carbon dioxide, carbon monoxide, or methane. So we can get mesoporous particles by using a thermal decomposition method because of evolution of different gaseous byproducts. I'm going to discuss about the properties of nanoparticles. So first one is optical property. Nanoparticles have a very peculiar optical behavior, particularly the color of a nanoparticle depends on their sizes. For example, bulk silver, the color of bulk silver is white. Suppose the silver nanoparticles have the size range from 480 to 1100 nanometer, that color will change from orange to violet. Similarly, gold and platinum nanoparticles also show the unique color behavior. And another one is solvent affinity. Generally, bulk material, some of the bulk inorganic material may not be soluble in water. In case of its nano form, we may get the colloidal or even like a two solution. For example, gold colloids we can prepare. You know that gold is insoluble in water, but if you reduce their size, we can get gold colloid, gold nanopart colloid solutions in water medium. Similarly, we can also get Fe2O3 colloidal solutions. The dispersion of nanoparticles in water is because of their interaction with the solvent particle. So we should understand that the interaction between the solvent and the nanoparticles will be strong. Then only the density won't affect the colloidal solution. If the interaction is more, if the interaction more means we can get the colloidal solution. Suppose if the interaction is very less between the nanoparticles and the water, then easily they will settle down and instead of colloidal solution, we're going to get the suspension. So another one is a magnetic property. Some of the nanoparticles have highly magnetic characteristics, particularly iron, cobalt, and nickel-based material. And the nanomaterials also shows different magnetic behavior. For example, bulk Fe3O4 has a ferrimagnetic nature. Suppose if you prepare Fe3O4 in the nano form, we can get super paramagnetic nanoparticles. The same Fe3O4 in the nano form will show super paramagnetic. Super paramagnetic is nothing but the thing super paramagnetic is very unique when compared to ferrimagnetic. How? If you disperse the Fe3O4 nanoparticle in water, we can get colloidal solution. It's possible. But in the presence of external magnetic field by using external magnet, the nanoparticles, the super paramagnetic nanoparticles attracts to each other and we can get the suspension. Again, if you remove the external magnetic field, then we can again get the colloidal solution. This is possible only with the super paramagnetic nanoparticles. In case of bulk Fe3O4, that is in ferrimagnetic character, we can't get this colloidal solution. If we put the bulk Fe3O4, we're going to get only the suspension, not the colloidal solution. This is the difference between the nanoparticles and bulk materials. And melting point, generally, a depression melting point is observed for a particular material when its size goes from a millimeter or micrometer into nanometer. For example, gold nanoparticles with a 2.5 nanometer size shows a melting point of about 300 degrees Celsius. But you know that bulk gold will only melt at 1164 degrees Celsius. And another one is mechanical property. So nanomaterial possess good mechanical behavior. For example, if you take a super alloy, Inconel 625, the strength of this alloy can be further improved by adding titanium dibromide nanoparticles whose size is in the 58 nanometer. So we can also improve the hardness or mechanical properties of even polymers by adding metal oxide fillers. Now let's see the application of nanochemistry. So nanoproducts are widely used in different fields. Nanomaterials also used in textile industry. For example, nanoparticles, particularly hydrophobic nanoparticles, are coated in fabrics to create water repellent fabrics. Such kind of fabrics will be more useful in laboratory to prepare to form the apron or lab coat. Antimicrobial songs have also been produced by using nanoparticles. So when we use salts continuously, then during microbial action and sweating causes some bad odor. To avoid such bad odor, nanoparticles are used. So generally silver nanoparticles are used in antimicrobial salts. Similarly, flame retardant fabric are also produced by using graphene nanoparticles. So flame retardant fabrics means it has resistance towards flame. Nanoparticles are also widely used in cosmetics. Different nanoparticles like titanium dioxide, zinc oxide, or even lipid nanoparticles are example for organic nanoparticles, bacchymesophyllurines, nanosilver and gold, zinc ferrites, such kind of ferrite materials. This kind of materials are used in cosmetics and in food industry, carbon nanoparticles are used as a colorant. Black-colored ice creams can be prepared by using carbon nanoparticles. Nanoparticles like a vitamin and protein are also added to food as an additive material. Food packaging materials also prepared by using methoxy nanoparticles or composite nanoparticles, which consists of cytosine like cytosine biocompatible materials. The application of nanomaterials in agriculture sector is fastly growing. Particularly, nanomaterials are employed as a pesticides. Pesticides are materials which kills the unwanted weeds or microbes or phytopathogens. So silver, TiO2, carbon nanotubes are nowadays used as a nanopesticides. And the application of nanochemistry in the energy sector uh, is a huge. We can we can get hydrogen energy, and we can also get electrical energy by using nanomaterials. Water splitting reactions. You know that water will undergo splitting and it will form hydrogen and oxygen. This reaction can be performed by using nanomaterials and electricity. And solar energy can also be used, can also be consumed, and it can be used to produce electricity with the help of solar absorbing nanomaterials. Heat can also be captured by nanomaterials, and that heat can also be used to produce electricity. Another important field is medical field. So nano materials are used in medicinal in a medical field, both in therapy and diagnostic purposes. MRI imaging and some scanning purposes, nanomaterials are used. Nanomaterials are used to deliver the drugs in a targeted sites. That's called the drug delivery system. And in photodynamic therapy, nanoparticles are used. So nanoparticles are also widely used in the environmental remediation, particularly in water pollution remediation and atmospheric air pollution remediation to decontaminate the pollutants from the soil. For example, the dyes. The dyes can be decolorized by using Fe2O3 nanoparticles. Now, I want to conclude this lecture. So far, we have discussed that nanoparticles can be synthesized by different methods, like a precipitation method, hydrothermal method, thermal decomposition method, hydrolysis method. The properties of nanoparticles are entirely different from their bulk state. Nanoparticles, different kind of nanoparticles are widely applied in different sectors like medicine, energy, textile, cosmetics, So we can say nanoparticles are used in almost all sectors. So we can say it's a nano world. We are living in the nano world. So I would like to thank you again, our professor, and you all. Thank you very much for listening my lecture. Thank you.